Okay, we're going to set up our Power Lab write-up now. So you've ran up the stairs, you've timed it, you measured each stair, you've massed yourself or weighed yourself and converted it to mass. And so now it's time for the write-up. So the first thing you got to do is you got to collect some uncertainties in those values you recorded. So for instance, the height of a stair. So how high was each stair and what was your uncertainty in that height of one stair? And then you got to extrapolate that to the uncertainty of all the stairs. Now remember, when you pick an uncertainty, you have to justify why was it that value. You can't just say, it's this. You got to justify why. Same thing for your mass. So maybe you use that scale in the front of the room that measured in kilograms. How accurately could that scale read your mass in kilograms? And again, use that to justify your uncertainty. Now the uncertainty in the time I gave it to you as 0.4 seconds. Now that was given because it takes me a second to say ready, set, go. And assuming that, as soon as I hit that and say go, you start. So I gave ourselves a little bit of leeway at that start because that's where most of our uncertainty in that time is going to come about, maybe 0.3 seconds. And then when you get to the top, me timing it for when you hit that top step, I'd say I'm within 0.1 seconds. I'm pretty on that. So I gave us 0.4 seconds there. How do these uncertainties change the power? Okay, so now we have to say, well, how does the height of the stairs, so if the stairs were taller than I thought they were, how would that affect the power? Would I have had more power or less power if I had higher stairs? Or if I had a higher mass than I expected? What would that do to the power? Would it make it more or less? Same thing with the time. If I had a longer time period, what would that do to the power? Would it make it more or less? So you got to figure out what type of relationship. You're going to need to know this so that you know, should I add the uncertainty or subtract the uncertainty? Because the next step is we're going to use the over-under method. So in the over-under method, we're going to have to figure out what would our maximum power possibly be. So should I do the highest stairs, the highest mass, and the shortest time to get my highest power? Okay, well then, in order to do that, plug it in. Change those heights of the stairs, mass, and the time accordingly so that you get the highest power possible, and then change them accordingly to get the lowest power possible. Take the difference, divide by 2. This will give us our uncertainty in the power. We call it sigma here. And that uncertainty in our power record, it just say my power was this plus or minus that. So for instance, I had 1.2 horsepower plus or minus 0.2 horsepower in uncertainty. Now, that's all good and fine, but I want to know, how big is that uncertainty? Am I very uncertain about this, or am I slightly uncertain? How certain am I? And so what we can do to talk about that and give it a relative size is we can do something called percent uncertainty. So we take your uncertainty divided by your power times 100. Okay? So for instance, here I had 0.2 into 1.2. So not exactly the easiest math, but maybe that was that 17% uncertainty about. And so 17% uncertainty is that's how certain I am that my power is 1.2 horsepower for running up those stairs. Now we didn't do multiple trials, that was just a one trial thing, so we would have maybe a higher uncertainty, and then what would be my maximum power for going upstairs. So maybe it would take multiple trials next time. All right, there you go. You can go ahead and write that up. And as always, turn it in early, get some feedback, and then fix things and turn it back in. Make sure you get the best grade you can and show all your knowledge on that lab.